Hello, my name's David Cole and I'm Technical Director at Penstock Solutions. Today I'm going to talk to you about containment valves. For what we're talking about today is a containment valve is a valve specifically designed to stop the flow, the drainage pathway flow, so that it doesn't carry out into the receptor. So if you're looking at containment valves, you're probably looking at you've got a firewater or a pollution risk that could leave your site and cause a pollution event. So that's where a containment valve comes in. A containment valve does exactly what it says. It stops the flow dead and allows it to build up behind the valve. So what I find is that often engineers specify the dreaded word Penstock valve. This is a very generic term and probably 10 years ago was used a lot in guidance notes. You could see it everywhere. If you read things like Series 736 now, it doesn't mention the word Penstock valves. It mentions containment device, pollution containment device. Therefore, what you're looking for is a valve that actually seals. The danger is when you take the term Penstock, you're actually looking, as the English dictionary says, it's a flow control device. They're different. You've got a valve that's quite slow, that was designed to stay in place for many, many years, but slow and control the flow, not necessarily isolate that flow. So when you look at a containment valve, which is toggle block or a device that's similar like that, is what it's there to do is immediately or as fast as possible stop a flow dead so it cannot carry on down a pipework. So when we look at our containment valves and toggle block in particular, we've got it connected. It can be connected into a simple smartphone device, but it can be connected to a button that somebody just presses, a remote button. It can be connected into your fire alarms. In fact, it's actually endless. Anything that creates an alarm input can be used to operate a valve. So what you've got is, there's a benefit by having an automated valve. It means it takes the human element out. So if you've got a valve that obviously you have a pollution incident and you're relying on a human being, which might be something like a Penstock valve or a simple manual containment device, somebody has to go and operate it. That means that person needs to understand what they're doing. If we then look at automated pollution containment devices, these devices are connected up to intelligent pieces of equipment. So if an alarm automatically goes off, it shuts a valve, it closes the valve, it tells you that it's closed the valve, it documents the time, the date when that valve was activated. So you've got a chain to actually look at. So if you did have a pollution release because something had happened, you would be able to evidence to the regulator that the system you had in place was operational. So containment valves can vary. I mean, it's quite an open-ended. We would probably say that you're probably looking at a starting figure of about £6,000 and carry on upwards depending on how many containment valves you need, how big they are, how complex the system is that you want to run them off. But this is nothing compared with probably looking at the size and actually being able to put in an automated Penstock system where you've got to get mains power to it. These are quite an affordable piece of equipment, but you must remember they are designed to isolate that drainage flow completely. They're not really designed for controlling a flow. They're there to stop a flow so an incident, a pollution event doesn't happen. So installing pollution containment valves isn't as simple as most companies think it is. What you need to understand is, if you stop a flow, for instance, in a drain, where does it lift? Because it's not necessarily you put a valve at the end of the line and it will fill up and pop out at the other end of the line. Sites aren't flat. Sites are different. So if you put a valve in the wrong place, what you could end up is that a valve could hold no more than probably 10, 20,000 litres of liquid, which isn't much if it's raining at the same time as that pollution event. And it could pop out and find a pathway off the site through the natural roadway. So what you have to do is you have to understand the risk model of actually what does the site look like? What is the drainage underground network like? And then what is the above ground topography like of the site, so you understand exactly where to put that valve. It's really critical to know where to put a valve though, because it can be the difference, as we've found, where sites have gone, we've got four drainage outlets, we need 4 valves. When actually you understand the model and the risk, you find out they only actually need 2. They hadn't really looked at how drains worked on their site. So pollution containment devices, in my opinion, shouldn't be connected into your main supply. and shouldn't be reliant on some sort of backup generator that's got to kick in. You need systems like this to be totally independent. They've got to be standalone. So what we have a tendency to use, we have a tendency to use battery power, we use solar energy, we use wind energy, whatever it is, but we will not really connect them into the mains. What we're looking at here though is a system that's standalone, because normally that valve needs to be replaced in a location that you probably haven't got services to in the first place. So you need to keep it relatively simple, because the majority of your cost of an automated Penstock valve with, say, a 3-phase motor on it is actually getting the services to operate that valve. Critical to that though, in the event of a fire or a power failure, is the very valves that you need to operate when you have a pollution incident actually don't have any power. And that is totally the wrong way to look at it. Any pollution containment device needs to work without power. It needs to be able to operate off its own internal power source. When we make the valves now, ours actually tell you if there is a problem. So if you have got a battery drain and you've got a battery that's going into failure, it'll actually send you a message to say this system is going offline, there's going to be a problem. If you don't look at it in the next month, you won't have a system that's operational. So there's all sort of controls put in place. But you must always, with containment systems, they should be offline, they should be standalone. So as I've just said, is the installation when you're putting one of our toggle block systems in, really what you've got is you've got 3 air lines. These 3 air lines are one to open and close the valve, obviously, and then you've got another one which is actually how we know when the valve is in an open or a closed position, which is quite important, because if you've operated a valve, you need to know whether it did close, essentially, or did it open after you've had an incident. If you start to look at that type of device, you've got to get a duct, but a relatively small duct. It's an unpowered airline, so there's only ever air on that system when it's operational. The whole system is 12 volts. It's relatively therefore safe. You're not going to get electrocuted. Whereas if you start to look at a control system, you've got to get mains power to it. And normally that means you either got to get mains power to an actuator below the ground, which now you're putting it into a chamber, which could have gases in it. Therefore, you probably need to look at ATEX. So you've got a much more expensive unit, and you've got an explosion risk, you've got a health and safety risk. So what you're doing here is you've actually got, for all you're looking to do is close a valve. So make it simple. Make it so that all you've got is one function. Keep it simple by using a system that's totally self-powered. Nice and simple, small little 300 square box that sits with a little 10-watt solar panel sat on it. Fine. You can mains power them if you want, but we would always advise you not to. So a major benefit with obviously fitting a standalone valve is you're not putting services to it. You don't necessarily need to build a massive deep trench that actually carries these powered cable conduits. It's nice and simple, and because the valves we actually make are what we call modular, so they're very, very lightweight. If you take, for instance, a 600mm valve of a toggle block size, it's something in its modular form that easily a person can pick up and lift. If you take that as a Penstock valve, you'd need a crane. So the device you've got as well is that once it's in the ground, it can actually come out again. It can be retrofitted to the existing infrastructure without really any real major design changes to the drain. So our recommendations are is that you follow our 6-point process, which is really understand the regulations. Then understand the regulations that affect your business and how they're going to affect your business. Carry out a risk assessment, fully risk what actually you need to do, what you're trying to achieve. Then you need to make a design, create a design so you understand what that design is going to be. Then build and install the design, put it in place, get it working. And then maintain, monitor and document the system that you've installed. Make sure you keep it up to date and well maintained. Don't forget that as guidance changes, as new technology comes through, you need to be on top of it. You don't need to just sit with the equipment you put in years ago. You need to keep up to date. So if you need to know any more, why don't you contact us at www.penstocksolutions.co.uk.